All right. Hello. I'm Shai. This is a joint work with Hanan, who's over there, and VC from UCI. So first of all, what are order effects? Let me ask you a question. Which color is the best color for a child's room? So would you say it is aqua mist or sky blue? No need to vote. I appreciate your input. Okay, let me ask, okay, now forget about this. Let me ask you a completely different question. Which color is the best for a kid's room? Is it sky blue or aqua mist? Okay, so theoretically the answer you give should depend on the order, but if it does depend on the order in which they're presented, this is an example of order effects. They're also called position biases. And the two best known examples are primacy effect or primacy bias, where the option you see first is disproportionately preferred. So in this case, if I gave you these two choices, you would just always choose the first one. And the other one is the recency effect, or the recency bias, which is the last one is shown is disproportionately preferred. Maybe in this case you wouldn't care about it that much, but they can be problematic. So they may distort true preferences. So the choice actually may reflect the presentation order instead of the underlying value. And this leads to choosing the worst option. This might lead to choosing poorly, basically, just because of the order the options were presented. This in turn leads to reduced fairness, reduced trust in the system. Outcomes can seem biased, can seem arbitrary. And if this can accumulate. So if you have several decisions, one following the other, even these small errors could accumulate into very bad decisions. A lot has been done on order effects. So here's the references. This QR code is going to appear a lot, but it's going to be smaller every time because I want to incentivize you to scan it earlier on. So scan it whenever you want. I'm just saying it's going to get harder, but you do you. So we know that humans display recency biases, and we know that humans display primacy and recency biases, and there's a bunch of other position biases that we know about, and people have observed order effects in LLMs a lot. So in multiple choice, if an LLM is not sure what the correct answer is, they tend to choose a specific option. Kind of similar to humans. If you're not sure, you choose C. Right? We all know that. In classification task, in pairwise evaluation, similar to what I've shown you, and specifically primacy and recency have been observed in large language models. More often than not, people have observed primacy. Occasionally you see recency, but it's basically been predominantly primacy, and we actually help explain why that has been the case. And a lot of papers have observed that we actually seem to see these when the options are similar in quality, which is not surprising, right? This is not surprising, but a lot of papers have observed that this is when we're more likely to see order effects. I'll show in a second why that is important. So our research questions, as you can see, they're slightly embellished, but essentially these were the research, close enough to the research questions we set out with, is do LLMs and humans display the same order effects? Another question is how strong are these effects? So it's been observed that they occur when options are similar, relatively close in quality, but these could be manifestations of two different phenomena that are actually, it's really important to differentiate between them. They could just be a tie-breaking heuristic, right? You don't know which answer is correct, you're going to choose C. But it could be that they actually reverse true preferences. So it could be that I give you an option because I showed it to you first, you choose that, and it's actually the worst option. It reverses your underlying preference. And previous researchers mostly ignored this distinction. But like I said, they have noticed that it tends to happen when the LLM appears indifferent between them. So that does seem to favor the tie-breaking explanation. And there is one paper that we found on the study in humans that asked this question. It's a bit of a mess. I'm happy to talk about it afterwards. Also, you can see it in the references. The conclusions are unclear. Another question that we wanted to ask is what affects these order biases? And lastly, how do they interact with other biases? So we set out asking about gender, but as we'll see, we found some other interesting biases. Okay, so our first conclusion is, or our first observation is, LLMs appear to exhibit unique biases. So we found two biases that have not been documented in humans. I don't claim that they don't exist, but there's been a lot of research and they've never been documented. So I believe that they don't exist in humans, but again, I can't prove it. One is centrality bias, which is bias towards the middle option. And the second one is a really weird name bias, which I'll get into. We find that order effects can actually reverse underlying preferences. So a strictly inferior option may be recommended by the LLM. It's not just tie breaking. We present a new mitigation technique to mitigate LLMs. It's kind of simple, maybe intuitive once you think about it, or maybe counterintuitive. I prefer to think of it as counterintuitive. It's actually increasing the temperature. So typically we associate increasing a temperature with reduction in accuracy. We actually increase the temperature to gain more accuracy. We find that order effects are quality dependent. This has also not been observed in humans, but it seems to be very strong and prevalent across every LLM we tested. So higher quality options, the LLM tends to exhibit a primacy effect. When they're lower quality, it prefers the later options. And order effects are much stronger than gender bias. I'm not going to cover this in this talk. Okay, I'm going to kind of be a bit more brief about these. I have more information in here for you people watching online, and you can take a photo. I'm not going to go into too much detail here. But we asked different LLMs, mostly ChatGPT 4o Mini, Claude 3 IQ, and Llama 3 8B, even though we did ask some other LLMs, to compare colors for a child's room, the example I gave you at the beginning, and job candidates, compare resumes. And these are very different domains, and we chose them purposefully because they are extremely different. So colors for a child room is minimalistic. There are no other biases. It's the cleanest example we could find. It's a low stakes situation. I know if you have a kid and you have to choose a color for their room, it seems high stakes, but and it's easily replicable. So you can run these very easily. Right? While I'm talking, you can replicate my experiments. And job candidates have been extensively studied. They're relatively high stakes, and they are used. So in practice, LLMs are used a lot in hiring, and actually, more and more, they are used by pairwise comparisons. And we tested pretty comprehensively all permutations, different temperatures, identical queries at the same temperature, and so on. So we used four different quality tiers. In colors, we call these ideal, fair, plain, and harsh. So ideal would be colors that we would consider ideal, and LLMs agree with us, sky blue, aqua. Fair are okay, light yellow, pale coral. Then the plain, not great, but off-white, oyster, white. And then there's colors which we all agree should not be the base color for a child's room, like hot pink or obsidian black. And you can see more colors. I'm not going to go over this. I'm going to leave it here for a second. We curated them by hand. We verified the quality differences. And then for resumes, similarly, we had four quality tiers. We called them best, good, mediocre, and weak. And we curated, or we generated resumes for four different professions, and they were named. So the resumes were all named. We have names, and we generated purposefully names that we did not expect would elicit any bias. So purposely generated so that they wouldn't elicit any racial bias or demographic bias. Common, American, Caucasian names, first and last names like Smith, Jones, Miller, James, Thomas, Emily. And we gave the following prompts. So basically, which color is best for a kid's room? The first color, the second color. And similarly for resumes, you're a hiring manager evaluating two candidates for the same job. Based on their resume, select the stronger candidate. We gave them both resumes. Okay, everything clear? Okay, so our results for pairwise color comparisons. First position, well, you can see first position is light, second position is dark, and you can see it's basically very clear bias. When the options are relatively high quality, so ideal, like blue and cyan and aquamist, it just chooses the first one. When they're low quality, chooses the second one. So the threshold varies between the large language models, but it's pretty consistent. All large language models, when they're good options, it chooses the first one. Bad options, choose the second one. And similarly for resumes. Good options, it chooses the first one. Bad options, choose the second one. All of these examples, so this is consistent across all LLMs. High quality, we get primacy. Low quality, we get recency. I'm going to focus on temperature zero. Everything's been temperature zero, but I'm just going to show you that this holds in exactly the way you would expect. When I raise the temperature, if I raise it to 0.5, you get more stochasticity. I raise it a little bit more stochasticity, and so on. Right? So exactly what you'd expect. So I'm not going to focus on that. So that's for pairwise comparison. Triplewise comparisons, we get something very similar. We still see the same effect. High quality, it chooses the first one. Lower quality, it chooses the later options. Similarly for resumes. But I think the most interesting thing is here, you can see that sometimes, in some cases, it chooses the middle option. Right? So it's very strongly biased towards the middle option. And we found that interesting because that does not appear to have any analog in humans. So basically, they didn't inherit this from human data. This is a new fault mode that LLMs developed by themselves, and both ChatGPT and Claude developed it. Interestingly, Llama doesn't appear to have this bias. I don't know why. Next result. If you'll notice, right, so the colors seem to be very clear. It's very clear that it always chooses the first one, it always chooses the second one. But if you look at, for example, just the results for registered nurse, in the good tier, it seems weird, right? There's no strict preference, but this is just two resumes. Why would this happen? And turns out this is just because there's 4 names. So we used 4 names for each gender. And this discrepancy is just led to this crazy bias of all LLMs really prefer certain names to other names. So Claude absolutely hates Andrew Harris. I don't know what Andrew Harris did to Claude, but it despises anyone called Andrew Harris, quite partial to Christopher Taylor. And you can see when we look at triple-wise comparisons, you can see that I'm not going to go over this in too much detail, but GPT has less bias than Claude. And if you can see overall comparisons, like it chooses Christopher Taylor basically almost 8 times as much as it chooses Nicole Harris. So it really likes some names. It really does not like other names. And again, this is something that has not been documented in humans. And I just want to clarify, we controlled for everything. Like all it is you take 2 resumes, switch the names, give all 4 permutations. It's really that simple. So it is a strong a strong bias for certain names. And finally, about whether it's tie-breaking or true preference distortions. So if you look at temperature zero, you really can't tell the difference, right? It always chooses the second option in this case. So if you ask it pale dinner or oyster, it's just going to choose the second option, whichever it is. And I can't tell if that's preference distortion or tie-breaking. Right? It could be either or from this. There's literally no way to tell. So what we do is we extend the rational choice model. Instead of just strict preferences, we're going to have stronger and weaker strict preferences. We're going to have robust preferences and fragile preferences, which are a bit weaker. And we just hand-wavingly, the definition here is susceptible to order effects or not susceptible to order effects, but true preferences. And this kind of allows us to distinguish between indifference and fragile preferences. Right, so here we don't know which one it is. So what we can do is we can raise the temperature. And you can see that this added stochasticity suddenly allows us to differentiate between the two. You can kind of see intuitively that it looks like pale linen it actually prefers pale linen. So if it's a fragile preference, multiple repetitions at a higher temperature actually allows us to get at the true preference. I'm not going to go over this slide, but I'm going to put it up here in case you want to take a look at it. And this is basically, one more slide. So we give two ways to mitigate the order effects. The first one is what I just said. You just sample at a higher temperature. And the second one is, actually we can use the position bias as a quality signal. Right? So if I give it two options and it chooses the first one in both times, I can say, okay, but this appears like a good option. So overall, main takeaways, LLMs exhibit different new fault modes, new failure modes to humans. So we found the quality dependent shift, the centrality bias, the name bias. And notice that because they're different from humans, they may be hard to predict. They may be hard. How do you go about finding these? How do you even look for them? And then we give some new LLM-specific mitigation strategies. So you don't have to just use the mitigation strategies that we know work for humans. We may be able to develop new ones leveraging LLM's unique, capabilities and qualities. And that's it. Thank you very much for.
Well, thank you, Shai, for some counterintuitive results. We have time for one question.
What's your theory on the name bias? Why do you think that comes
I don't even want to go there. I don't know. It was very surprising. So, we genuinely couldn't make heads or tails of what was going on until we looked for it. I don't know. Maybe there was. I don't know. Maybe it was one of the programmers at Anthropic was not nice. I don't know. I'm kidding. But I genuinely don't know. And for a lot of things, for these, I don't know.
You don't think it was a hallucination?
But it's it's very consistent. Statistically, this is not just me showing you some. It's very statistically biased towards, very clearly likes Christopher Taylor, does not like Andrew Harris. I don't know why. I agree, it's interesting. I haven't been able to figure it out.
Maybe one more.
Okay, go ahead.
Yeah, fascinating piece of research. However, I couldn't get rid of the question in my mind. To what extent is this possibly an anthropomorphic interpretation of what are in fact algorithmic features?
I'm not sure I understand. What do you mean?
Anthropomorphic interpretation meaning.
No, I know what that means.
Yes. So it becomes some sort of an explainability problem rather than it's a feature of the algorithm rather than a preference, a difference, etc.
I mean, I don't think so. I mean, I've never heard anyone at OpenAI say, oh yeah, what we've done is, if you give it good options, it's always going to choose the first one. This seems to be a failure, right? This is not what you would want your LLM to do. If I'm designing an LLM and I'm asking for it to recommend something, I want it to recommend the best option. I don't think a feature of these is to recommend the worst option because it was presented first. So I'm not sure if I'm answering your question, but this is not my interpretation. Objectively, this is what's going on. Maybe didn't completely understand your question, but we can take it offline now.
Yeah.
If I missed it.
Thank you so much. We can take questions offline. We will have 20 minutes for our coffee break, and we'll resume sessions at 3 p.m.